Today we unravel the mysteries of machine learning in our video series, Decoding Machine Learning, 10 Secrets for Data Mastery You Wish You Knew Sooner. Join us as we demystify the intricacies of data science, unlocking invaluable insights and techniques that will empower you to navigate the world of machine learning with confidence. 1. Understand your data. Performing data preprocessing tasks such as handling missing values, outliers, and ensuring data consistency is crucial for model accuracy. Feature engineering, another key step, involves selecting relevant features and creating new ones to enhance model performance. Selecting an appropriate evaluation metric tailored to the project's objectives ensures accurate assessment of model effectiveness. Splitting the data into training and testing sets helps gauge the model's generalization to new, unseen data. Regularly validating and updating the model based on changing data patterns is essential for maintaining its relevance over time. Lastly, documenting each step of the data exploration and model development process promotes transparency and facilitates collaboration within the team. 2. Feature engineering matters. Consider leveraging domain knowledge to create features that capture intricate relationships within the data. Exploring different transformation techniques, such as scaling or normalization, can further improve feature quality and model interpretability. Iteratively refining features based on their contribution to model performance helps identify the most influential variables. Techniques like dimensionality reduction, such as principal component analysis, PCA, can be applied to streamline the feature space while preserving essential information. Regularly reassess and update features as the data evolves to maintain model accuracy. Collaborating with domain experts and employing automated feature selection methods can streamline the process, ensuring that the selected features align with the problem at hand and contribute meaningfully to the model's predictive capabilities. 3. Data preprocessing is non-negotiable. Impute missing values using appropriate methods, such as mean imputation or advanced techniques like nearest neighbors imputation. Detect and handle outliers using statistical methods or robust algorithms to prevent them from disproportionately influencing the model. Employ techniques like feature scaling, such as min-max scaling or standardization, to bring all features to a similar scale, preventing any particular feature from dominating the learning process. Consider using techniques like one-hot encoding for categorical variables to convert them into a format suitable for machine learning algorithms. Explore the impact of different encoding methods and choose the one that best aligns with the data characteristics. Regularly validate the effectiveness of the preprocessing steps by monitoring model performance on validation sets, ensuring that the chosen techniques enhance the model's ability to generalize to new data. Finally, document the preprocessing steps thoroughly to maintain transparency and facilitate reproducibility in future iterations of the machine learning project. 4. Split data for training and testing. Consider implementing a validation set to fine-tune model hyperparameters and prevent overfitting. Stratified sampling can be beneficial, especially when dealing with imbalanced datasets, ensuring that each class is adequately represented in both training and testing sets. Keep a consistent random seed during the splitting process for reproducibility. Regularly reassess the split ratio based on the size of the dataset, ensuring an appropriate balance between training and testing samples. Implement cross-validation techniques such as fold cross-validation to robustly evaluate the model's performance across multiple subsets of the data. Monitor key metrics such as accuracy, precision, recall, and F1 score to gain a comprehensive understanding of the model's strengths and weaknesses. Adjust the split ratio and cross-validation parameters iteratively based on performance evaluations, refining the model's ability to generalize effectively. 5. Choose the right model. Consider the interpretability requirements of your application, as some models provide more transparent insights into the decision-making process than others. Evaluate the scalability of algorithms with respect to the size of your dataset, ensuring computational efficiency. Experiment with a variety of algorithms and compare their performance metrics to identify the one that best aligns with your specific problem and data distribution. take into account the potential need for ensemble methods, which combine multiple models to improve overall predictive accuracy. Regularly revisit the choice of algorithms as your project evolves, especially if the nature of the data or problem statement changes. Leverage domain expertise and consult with colleagues to gain valuable insights into the applicability of different algorithms. Document your rationale for selecting a particular algorithm, fostering transparency and aiding in the reproducibility of your machine learning pipeline. 6. Hyperparameter tuning is essential. Consider employing more advanced optimization methods, such as Bayesian optimization, to efficiently explore the hyperparameter space and converge to optimal values. Implement a systematic approach to hyperparameter tuning, prioritizing the most impactful parameters based on their influence on model performance. Regularly validate the model on a separate validation set during the tuning process to avoid overfitting to the training data. Utilize model evaluation metrics to guide hyperparameter tuning, selecting combinations that enhance metrics relevant to the problem at hand. Experiment with different optimization strategies, learning rates, and regularization techniques, ensuring a comprehensive exploration of the hyperparameter landscape. Keep a record of the hyperparameter tuning process, including successful and unsuccessful attempts, to inform future iterations and improvements in model architecture. 7. Avoid overfitting and underfitting. Apply regularization techniques such as L1 and L2 regularization to prevent overfitting by penalizing overly complex models. Experiment with different regularization strengths to find the optimal balance between model complexity and generalization. Employ early stopping during training to prevent overfitting by halting the process when the model's performance on a validation set plateaus or starts to degrade. Utilize cross-validation to assess the model's generalization across different subsets of the data, helping to identify and address overfitting or underfitting. Plot learning curves to visualize the relationship between model performance and training dataset size, gaining insights into potential underfitting issues. Regularly revisit the model's complexity as the dataset evolves, adjusting hyperparameters and regularization strategies accordingly to maintain an optimal balance throughout the machine learning project. 8. Evaluate model performance. For imbalanced datasets, where one class is dominant, metrics like precision, recall, and F1 score provide a more nuanced evaluation of model performance than accuracy alone. Precision reflects the model's ability to correctly identify positive instances, while recall assesses its capacity to capture all actual positives. F1 score harmonizes precision and recall, offering a balanced measure. In binary classification problems, the area under the receiver operating characteristic, ROC, curve provides insights into the trade-off between true positive rate and false positive rate at various thresholds. Tailor your metric selection to the specific goals of your application, considering the potential consequences of false positives and false negatives. Regularly reassess and fine-tune the chosen metrics as project objectives evolve, ensuring alignment with the desired outcomes. 9. Stay informed about new techniques. Actively engage with the machine learning community by participating in conferences, workshops, and online forums to stay informed about cutting-edge developments. Follow key researchers, publications, and organizations in the field through social media and academic platforms. Experiment with implementing state-of-the-art models and techniques in your projects to gain hands-on experience with the latest advancements. Consider joining collaborative projects, open-source initiatives, or contributing to repositories on platforms like GitHub to foster knowledge exchange and collaborative learning. Enroll in online courses, certifications, or advanced degree programs to deepen your understanding of emerging concepts and methodologies. Cultivate a continuous learning mindset, as staying abreast of advancements in machine learning is essential for maintaining relevance and driving innovation in your projects. 10. Interpretability matters. Prioritize the use of interpretable models, such as decision trees or linear models, when transparency is paramount. Feature importance analysis can provide insights into which variables are driving the model's decisions, aiding in the interpretability of complex models. Utilize techniques like SH8AP, Shapley additive explanations, values, or LIME. local interpretable model-agnostic explanations to explain individual predictions, making the decision-making process more understandable. Regularly communicate and collaborate with domain experts to ensure that the model's predictions align with existing knowledge and expectations in sensitive domains. Document and share interpretability insights with stakeholders to build trust and facilitate decision-making processes. Strive for a balance between model complexity and interpretability, tailoring your approach based on the specific requirements and ethical considerations of the application. As we conclude this insightful exploration into machine learning secrets, we hope you've gained a deeper understanding of data mastery. Don't forget to like this video if you found it helpful, subscribe to our channel for more engaging content, and share your thoughts in the comments below.